I think I am like now. Can you confirm if order and everything is I will really wait for 5 minutes before the second time around 2:50 and then we get started. Until then, if there are some questions from the chat, I will be happy to answer them. Not available. Okay, let me try this. Like, I'm not even like, I was not speaking anything there. I was able to solve first five problems, so I would be discussing them. Although, like, fifth problem was more related to ABCD rather than anything else over there. But I guess I would discuss like what I coded in the function, what ended up getting ABCD. And I did write the data counter test case for it, but I barely getting counter test case. But then, like, let me try once again. Hello, hello. Hello, hello. Okay, now it's good. Like, okay, like, it sound better now. Like, probably, like, the thing is, when I continuously speak, like, sound is little bit better, but when it's between, like, थोड़ा सा loud. I'm not sure, like, if I end up changing some settings over there, like, it may impact. Like, probably, can you try raising volume of it once? If it's still broken, it says sound is not audible, like, maybe it's broken, like, sound. Let me just try a few more things here, like, one second, like, I will, like, can anyone confirm and audio and everything is fine now? Like, I ended up solving like first five problems, so I would be discussing them. Like, can anyone confirm if audio and everything looks better now? Hello, 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 hello. Yes, better. Thanks everyone. Let's get started. Like, it's also scheduled time. Right? I would start from the first problem. First problem says, like, first problem says two friends. Monoka wants to throw a party. He has nine friends and he wants to have at least two of them at his party. I friends best friend is PI and all PI everything, and also for all I learned from about that, PI is not good. Monocat gets an invitation to friends. The other friend comes to the party if both I friend and PI friend receives an invitation. Note that PI friend doesn't have to actually come to the party. Each invitation is sent to exactly one of the friends. For example, if P equal to 31254 and Monocat sends invitation to friends 1245, then the friends 245 will come to the party. The friend 1 won't come since his best friend didn't receive an invitation. The friend 3 won't come since he didn't receive an invitation. Calculate the minimum number of invitations Monocat has to send so that at least two friends come to the party. Like, sound is like not really sure like what this is like settings and everything is still the same. Hello, 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 hello. What is a way to take part in the first contest? In past contest as well as possible participation content. It is supported only ICPC mode for virtual contest. If you have seen this problem, a virtual contest is not for you. Solve these problems in that. If you just want to solve some problems from a contest, a virtual contest is not for you. Like to be honest, like I am not really sure like what did something change today. Hello, hello. Like I restarted everything and I hope like it's better this time. Okay, it's okay now. Okay, so like the first problem like basically says okay, like that's like I have read the problem A, I think, and like I will probably start solving now. Okay, let's get started now. Okay, problem A. Problem A says like we have some n people and ith person has p-ith person as the best friend, and ith person will come to the party if his best friend is also invited. And it says like what should be the minimum number of invitations we will have to, and like it asks like minimum number of invitations we need so that at least two people come to the party. My claim is like if like it should be always possible like the number of people, let's say like if we invite three people, like one way to invite to get two people is to invite first person and his best friend p1, we invite second person and his best friend p2. Now there are four invitations, like there are four invitations and one and two will come to the party. Can we do something better? Yes, we can definitely do better. Like let's say we invite first person, we invite also p1, and we also invite the best friend of the first person. Like basically we invite one p1 and we also invite p1's best friend p of p1. In this case there are three invitations and both like one and p1 will come to the party. So this way also like using three invitations we can, two people will come to the party. Like we first saw earlier one method using where we would give four invitations and two people will come to the party. Then I said one more method where like we invite one best friend of one and best friend of best friend of one. In this case there would be three invitations because one would be coming because best friend of one got an invitation. Best friend of one will also come because best friend of him, like the other person also got invited to the party. So like the answer is always like, then we can say like the answer is always less than equal to 3. The question is, can two people come with only two invitations? This happens only when like there is some number A whose best friend is B and best friend of B is again best friend of A. if there is a pair like this, then if you invite A and B, then because both are best friend of each other, both will come to the party. And two people will come. So the answer is like we check for this case. Whenever like there are two people, both are friends of each other. In that case, we will print 2. If there is does not exist any pair like this, then the answer would be 3 because we can invite one best friend of one and best friend of one, and we can always say the answer is 3 in that case. And like this was the idea I had in this problem. Okay, like I will go through problems from A to E. So like I say the answer is 3, but if like let's write it probably in some better way. My default answer is 3 because I can always invite one best friend of one and best friend of best friend of one. Let's look at best friend of B. Best friend of I, it would be some best friend. And if best friend of A is again I, then in that case the answer is 2 because like we can invite I and best friend of I. And like that was the idea I had for this problem. So like this was the idea I had for this problem. And I will move to next problem then. Like if there are any questions on this one, like before we move to the next problem. Okay, moving to the next problem then. So like problem B. Problem B says shifts and sorting. Let's define a cyclic shift of some string S as transformation of string 1, some transformation where last character comes to the front. In other words, you take one character Sn and place it before the first character while moving all the characters to the right. You are given a binary string S consists of zeros and ones. In one operation, you can choose a substring SL to SR and cyclic shift it. The cost of such operation is equal to R minus L plus 1, which is the length of chosen substring. You can perform given operation any number of times. What is the minimum total cost to make S sorted in the non-descending order? So like it says, like problem statement says, like we have some string binary string which consists of zeros and ones. And like we can take some substring, let's say like this as a string, and then we can remove like the last character from here and put it into the front. And the cost to move it is like the number of characters involved over here, which would be 4 here in this case. So like at the cost of 4, we can get a new string S1, S2, S3, S4, S7. Like S4 should come before S7, and so on. S5 in between, and so on. So it says like we want basically like non-descending order. Non-descending order means like basically it should be the sorted string at the end. So final required string we want is something like that. Like where all the zeros come before it and then all ones come after it. And it asks us to like ask minimum cost to get this string. So like any ideas on this one? Like the idea I had was like, let's say there is some string which consists of 0, 1. let's say this is the string, and let's say we initially choose this string, and then if we move this 0 before all the ones, then the cost in this case would be 1 2 3 4 5 6 6. And like even after this is done, like we would have this as a string 0 0, and then like we would have to still move these zeros before these ones here. Like basically, like at first let's take any zeros and move it before all the ones we have. Or like basically, like let's say if we take this as a string, or like basically, like let's see, like there are, let's, yeah, probably let's look at it like this. Let's see, like this is the string. If we move this 0 before it, then at later point of time we will have to also move this 0 before this last one here. And like in that case the cost would be 2 plus the number of characters here. 2 plus 1 2 3 4 5 6. And like it's not optimal, like rather the other way to optimally do it would be take like all the ones before like whatever character you are choosing, and move that 0 before all the ones, and like that's the minimum you can get, and now that you don't have to do any operation with this 0. And like once you know this, like you can further simplify that it's always optimal. And even before, like let's see, like if this is the fixed operation we have, if we are fixing this character, we are getting extra cost because of these ones and zeros here. Because like let's say if you move this 0 before it, you would get 0 0 1 1 0 0 1 0 1 0 0 1, and you will have to still fix these zeros here. Rather, like if you fix these zeros first and remove it from here, like the number of jumps required would be less in that case. And like that's the idea. Find first 0 which has 1 before it, and make swaps there, make shift there. So basically, like if we take this as a string, what we will do is like this 0 looks fine, this 0 looks fine. So far this one looks also fine, this one also looks fine. Now this 0 is a problem, like this is not a sorted string we have. So what we can do is like now we can choose this as a substring, and we can move this 0 before this one. So like our new string becomes 0 0 0 1 1 0 1 0 0 1. Now like everything so far here is sorted. Now we have this 0 again. Now we have this 0 again, which is not sorted. We take it again and we move it into the front at a cost of 3 again. So like our updated string would become 0 0 0 0 1 1 1 0 0 1. Then we take this 0, move it to the front. Then we take this 0, move it to the front, and like everything becomes sorted here. So you can see that like whenever we move like the first character, the number of length is number of ones before 0 plus 1. Like because like you can see like when you are moving here, there are 2 ones before this 0. So the length over here is 3. So what we can do is like we can keep a track of count of number of ones we have reached so far, and then we add plus 1 to get the current length, and we can keep doing it. So like let me probably, so like my answer is 0. I also keep a count of number of ones. If current character is 0 and there is some 1 before it, Then I add answer to the count, answer plus equal to number of ones plus 1 for the current character. And if current character is 1, I increment the number of ones I have so far, and at last I print the answer. Like this was the solution I had for this problem. Any questions on this one before we move to the next problem? Like the idea is find the first zero and move it first zero which has some ones before it, like first character which is at incorrect position, and move it to the correct position by moving it before the nearest ones we have. And if you keep doing it greedily, at the end you will get the sorted string, and whatever cost you have got is minimum there. Like any questions on this one or anything before we move to the problems? Like rating would probably be 1200 or 1300 something. I am not really sure about it. That would be. But that was the idea. If there are no further questions, then I will move to problem C. Problem C says minimizing the sum. You are given an integer array of length n. You can perform the following operation. Choose an element of the array and replace it with one of its neighbors. For example, if a equal to 312, you can get one of the arrays 332. Here, if you replace 1 by 3, 322. Here you replace this 2 by 1, or 112, like where 1 gets replaced with 3, but not 212 or 342. Your task is to calculate minimum possible total sum of an array if you can perform aforementioned operation at most k times. So first question I have is, like, let's forget about like this restriction. What is the minimum possible sum we can get of the total array if we can apply this operation any number of times? Let's say if k is infinity, like what is the minimum possible sum we can get? Yes, like people have answered it correctly. The answer would be n into minimum of array. And like any ideas how we can get this possible sum? The way to do it would be like, let's say like this is the array we have, a1, a2, a3 up to an. Like let's say this aj is the minimum element. We first replace it aj with aj plus 1 so that the next element also becomes aj. Then we also replace the next element with aj, and we can keep doing it until an also becomes aj. And then we can come to the other half as well. We can replace leftmost element with aj, like which is the minimum element, and then the leftmost to it, and so on until like a1 also becomes aj, where aj was the minimum element. So by applying n minus 1 operations, we can replace, we can make array like make all elements equal to minimum. And like this observation would be critical. Like this is one of the critical observation. The next idea here was, notice that this value of k is less than equal to 10. So my idea was dp. Minimum possible sum I can get, like dp jl, as minimum possible sum I can get for numbers a1 up to al, and I have applied operation 10 times, operation j times. Like any question in this dp set before I, like how I look at how to do these transitions here? Like dp j to l is, like we have numbers from a1 to al, we have applied j operations over there, and what is the maximum possible sum we can get? Now you can see like our answer would be like, for like we would need answer for n. How do I ever think of dp? Like probably I would say at least solve some starting problems for the dp. Like basically if some sub problem starts repeating, Like for example, in this case, we can see like what would the optimal state would like. We have some array. Either an would be replaced by something. In that case, like we can look at like what was the index that was replaced by an. Like let's say like an was replaced by an minus 5. So 5 operations were applied here. And we need the best answer we want for all the numbers from like we can apply k minus 5 operations in this part using like n minus 5 elements. Or like let's say if an was not replaced by anything, then an remains same and you have k operations for the first n minus 1 element. And you see like if you start looking at operations like this, then if you look at like basically these two elements as your dp states, then you can see like the answer will always be same if you have let's say 4 operations for the first 100 elements. And the best idea is like if you keep saving values like this, you would get the final value. Like you have 10 operations and 100 element. Either let's say you replace made a96 equal to a100 by applying 4 operations here. Then for the first 95 element, you have 6 remaining operations. Or let's say you have replaced a100 with 98 here using 2 operations. Then for first 97 elements, you have 5 operations. You have basically 8 operations. Or you did nothing for the 100 element. Then you can find the best answer you can get for the first 99 element using 10 operations and add whatever the value of a100 is there. And like that was the intuition for using DP here. Like whenever something starts getting repeated here, like the other way to look at would be like probably a 9800 is there, and then now you replace 96 with 97, then the number of operations can remain same, and like that was the idea. So like now the DP state is we have first j elements and we have like we have some L operations and we have J operations left with us. And what is the minimum sum we can get? What I will do is like I will apply let's say some operations on this side. Let's say on 5 elements here. And if I apply 5 operations on some 5 element, the best case scenario would be replace all with the minimum in this area. Minimum in this subarray. And like the number of operations required would be 4 operations. And pretty much that is the idea. Like L or I, whatever index you can say, like you will first start with you have first n elements and you have k operations left. Then you will make some part over here equal using whatever operations whatever you need. And then you will again solve like whatever with the remaining operations you have with whatever the remaining array we have. And like pretty much this is the idea for this problem. And like I will probably code recursive, like generally I code iterative, but yeah. Like let's code an iterative idea for this problem. Like probably let's define some global vectors. Like the last index we have, that I was calling as L before, and number of operations remaining. So if we have reached past 0, then we don't have to make anything equal, like I am using one base indexing. If remaining operations are negative, I will say I need infinite cost. Otherwise, if dp, like I have already computed like this value before, notice that by default I have assigned everything -1. So if current value is not equal to -1, then I already know like the answer for this part. Like my current answer, let's call it infinity. Like current number of operations, I need, and like current min as well, current seg min, I can assign it as infinite first, and current idx, which would be my current index. And like whenever I'm increasing, like the array which I can go up to keeps increasing. Current idx should be greater than 0. Then current seg min, like I can take whatever min I have so far with current seg min, comma a current idx, and like current value would be minimum of whatever dp value I have into solve for current idx -1. Like I have replaced from current idx to idx so far using like remaining operations. Plus like the number of elements used right now, that would be idx minus current segment, like everything would be replaced by the current min, and like this is pretty much the solution for this problem. Okay, like looks like something is wrong here. And then k is the remaining operations. Okay, yeah. Like this is the dp idea. Like to iterate idea again. Like we have some prefix of the operations, like let's call it like current idx we have, and we have some remaining number of operations with us. There would be some segment which should be applied from current segment to the end. This length can be 1, 2, or whatever we want, and then we would keep solving for the remaining part. So let's say if this length was 5, then using 4 operations we will make everything equal to all the minimum in this 5 element, and like we would have like the remaining number of operations over here as remaining, whatever operations we had over here minus 4 we have, and like this current index whatever it was, like here it would be current idx minus 5. We can keep solving it. When we move out of this part, then we say like we need like the sum is 0. Okay, so I have a doubt. For the smallest sub problem, won't the answer depend on the right element of the rightmost element? Like probably I would not say it would depend on it, because like we are trying all possible ways for this segment here. So like let's say like there is some minimum which must also go from this side and this side as well. Then like because we are trying all the possible segments here, like this right going to right will also be taken care of. Like tabulation approach is also possible. Like tabulation, if you by that mean if you mean iterative approach, then yes, iterative is also possible. Because like if we have some element which we want to move to the left and we also move it to the right, and like let's say it, in optimal solution it goes in this part, then when we are on this element, like our current segment when it becomes equal to this would be equal to min, and it takes care of whatever we want. So like, and like that is the thing here, like because like it's not necessary to like let's say we have first 10 elements and 5 operations, and we also have first 9 and 5 operations. It can be possible that the value of this is less than value of this, because like let's say 10 10 10 10 1, and let's say we have 4 operations, 5 elements 4 operations. So when you look at all the 5 elements, it's possible to make everything equal to 1 and 5. But if you only take this as a segment, then the answer you will get from this side would be 30. But because we would be trying all the possible array sizes for this one, like going to the left and going to the right, we would get whatever answer we want. Or like the other way, I think this is what you meant. Like let's say 10 10 10 1 10 10. These are the 6 elements, we have 5 operations. Answer here is 1 because we can make everything equal to 1 here. But if you try to find the maximum answer you can get for the first 3 elements by using like 3 operations here, like you would get 30. But because in the best case, like this will go up to this side. So when we are looking for the like whatever the segment we get, like we would also try out this segment where like everything becomes equal to this part. And like I hope that clears the doubt, like why the sub problem answer depends on the right part, but we would still get the optimal answer using this approach. Like because for 5 operations when we are trying to calculate answer for 5, we would definitely also try like this 6 length array, and where we would be replacing everything with 1 over there. So any questions on this one before we move to the next problem? Okay, how will the DP with if 10 1 10 10, like can you also say the value of k you need? 10 1 10 1, yeah. Like let's say like we need 3 operations here. Then the idea would be when we would try out like the value for this segment, we can probably take this as a segment. We can also take this as a segment and try to solve it. Like I can share the code for like probability tabulation and iterative approach. If we like if we set all the elements to 1, then sum of all the elements is 1 over here, right? And we like minimum possible sum we want. Like the other iterative approach would be like we have like by using zero operations up to 0 we can get minimum value of 0. Now we move as the right pointer. Like we take the length of subarray which ends at r, and like this because we need at max k operation, this length should be less than equal to k plus 1, and like this length should also be less than equal to the min or all the numbers we have. We maintain a min val variable which keeps the running sum of minimum elements in the right subarray. So far we are increasing boundary one at a time, and like this is the element we would have when we move to the current element. And like kt be the number of operations which are left for all the house before like whatever boundary we have in the length array. Then like kt, the initial number of operation plus length minus 1 would be the current number of operations used. R would be the ending index. This value should be equal to minimum of current value plus whatever length we have, whatever minimum value we have, like this is current segment, plus the maximum minimum sum we can get by using kt number of operations for r up to r minus length numbers here. And at last we should look at minimum answer we can get by applying 0 to up to k operations when the array ends at n, and see out answer. Like that was the code for tabulation or iterative approach you were asking for. So any questions on problem C before we move to problem D? I did wrote it directly, like basically DP states are important. Once you see the DP state, you can probably even do transitions in the iterative manner instead of recursive. Like in DP problems, getting with the DP states is the most critical part than writing it iteratively or recursively. So let's move to problem D. Alice and Bobs are playing a game in the shop. There are n items in the shop. Each item has two parameters: AI item price for Alice and BI item price for Bob. Alice wants to choose a subset possibly empty of items and buy them. After that, Bob does the following. If Alice bought less than k items, Bob can take all the items for free. Otherwise, he will take k items for free that Alice bought. Bob chooses which k items it will be. And for the rest of the chosen item, Bob will buy them from Alice and pay BI price for the item. Alice profit is equal to like whatever sum it gets from Bob, the items which Bob purchases them, not the free ones, and minus the original value it gave to get all the elements. In other words, Alice's profit is difference between the amount Bob pays her and the amount she spends buying the item. Alice wants to maximize her profit. Bob wants to minimize Alice's profit. Your task is to calculate Alice's profit if both Alice and Bob act optimally. So like this is again a game theory problem. Okay, why greedy doesn't work on seal? Probably I will get back to it after discussing this problem. And like the idea in the games like this is minimax algorithm. That is the brute force idea. You might want to read about it. Like probably, and like let's look at it the other way. How does the game happens first? We have some items I1, I2, I3 up to IN. Alice will choose some set of items from it. Let's say k equal to 2. Let's say Alice choose these 5 items I1, I2, I4, I6, I10. Now the like if we look at our formula, which is like amount Bob gives to Alice minus amount Alice spends. In this case, like the amount and like Bob wants to take this as small as possible. And now in this formula, you see like once we have fixed the 5 item, the sum of values of AI is constant. Like this is profit for Alice, right? And like Bob can take 2 items for free. Like once Alice has chosen whatever items it wants, let's say these are the 5 items Alice decided to posit. Now like this value is fixed. So like what can Bob do to make this profit minimum? Like the only way Bob can make this profit minimum is take costless item for free. So basically it looks at what is the maximum possible value of all the 5 items, take max 2 for free, and like pay cost of cheapest items. So for example here like B values, let's say 10, 20, 5, 100, 15. Then like Bob can take this 100, 20 and 100 as free and pay cost as 10 plus 5 plus 15 by least cost items. Like so like now like we know like for any possible set we know like what would be the cost Bob would be paying. Like Alice can definitely predict, like once he chooses some set of item, he can definitely predict what is the amount of money she will get from the Bob, right? So like because Alice can Alice will always take costless items for free. So let's sort all the elements in increasing order of BI. So let's sort the elements such that B1 is less than equal to B2 is less than equal to B3 is less than equal to B4. Like we can always do this thing, right? And now we know that like if Alice chooses less than K element, then like he would get no money from the Bob. So like if Alice chooses less than K element, then Alice should choose nothing. So that he pays nothing and he gets nothing from the Bob. So overall profit is 0. Otherwise, Alice must choose at least K item because otherwise his cost is going to be negative. And let's say Alice has chosen these items. Now we know that it's sorted in the increasing order. So Bob will take these 2 for free and he will pay the cost for these 2. And here like the profit he would get over here for this element would be B1 minus A1, B2 minus A2, B4 minus A4, and here it would be minus a whatever the value is, and here it's minus a. So now what we can do is we can iterate on all the such partitions. Here in this case, you see after this index, there are two items which Bob takes, and after this, Bob readily takes whatever it wants. So like we can try out all the partitions such that Alice will pick k items from here, and Alice can take as many elements as you want. And like for this boundary, like we can try over all the possible values from I equal to 1 to n. Like, does this make sense? Like, because like we have arranged the elements in the increasing order of BR. So Bob will always take the last k elements or for free, and for everything before it, it would pay the cost. So like we can try out the what would be the kth element, kth heaviest element we have. Like basically we can fix kth costliest item, and then we can take like some values from here. If we pick kth costliest element, Bob should take like if we fix the kth costliest element, then like Alice should take k minus 1 cheapest elements from this side, so that whatever profit it gets for which Bob takes for free is as minimum as possible. And from this side, like for each item, he would get AI. He would get BI my value from Alice, and Bob, and AI would be his value. So if for any element like this is greater than 0, if this is greater than 0, Alice should take it, and if it's less than 0, Alice should not take it. So basically, we know our selling price and the buying price. So if selling price is more than the buying price, take it. Otherwise, leave it. And like this is essentially the idea for this problem. So we will try out all the boundaries for this purple index. And anything to the left of it, if selling price is greater than cost price, we take it. Otherwise, we will ignore it. And on the right hand side, like we will take k minus 1 items with minimum cost price. And like now you can try out like all the possible cases of this as a kth item, and like that is essentially the solution for this problem. Any questions on the idea so far before we move on to the code for this problem? Okay, now jumping on to the code for this problem. The idea is we can maintain a prefix sum for all the positive elements, like answer is our answer, like we assign it with 0. Like we call it a prefix sum. Like what is the profit we can get by only taking profitable items? And if current item is profitable, like I have already sorted the elements before. If current I is profitable, add that to the prefix sum. Now you can say like I am maintaining a priority queue type something so that I can get the cost of maximum k elements. Priority queue using a set and sum of elements in the priority queue. So like I insert the cost of for Alice for the current element in the set, and like I also increase like sum of all the elements in the priority queue I have. If size of priority queue is more than k, I look at the costliest item for Alice. I remove it from the set, and I also remove that value from the priority queue sum. And if the size of priority queue is greater than q, current cost would be priority queue sum. And if there are some remaining elements, then I can take all the profitable elements from like all the elements before it, and I take answer as current max with current cost, and at last I print whatever answer I have. Mhm. 1 second. Okay, the only issue is when k is 0. So like our answer would be max of answer comma like all the items we can get for free. Like not really sure like what is missing from the answer. Like I have. Mhm. A j minus x max and so on. Profitable items looks fine so far. Move current element to the queue. 1 second. Can anyone see some issue in this problem? I think my code is pretty much what I coded in the content. Okay, like this is the negative sum Alice would be paying for getting all the elements from the practical. And looks, yeah. Mhm. This was the solution for this problem. Any questions on this one before we move to the next problem? The next problem was pretty much proved by AC. Like I don't have any bound on like on the time complexity of it, but it looks like test cases were small enough to get an AC. Like there are many X on looks like looks like there are some successful act, and my solution might get hacked as well because like I don't have a proof for the idea. Like I can say what idea I had and like what did got AC on the pretest, but like I don't have a proof why it works and like why it should be enough. I did try creating counter test case for it, but at least I failed creating it. So yeah. So problem is says unique array. You are given an integer array A of length n. A subarray A is one of its continuous subsequences A L to R for some element such that L and R, one is less than equal to L, less than R is less than equal to L. Let's call a subarray unique if there is an integer that occurs exactly once in the subarray. You can perform the following operation any number of times, possibly 0. Choose an element of the array and replace it with any integer. Your task is to calculate minimum number of the operations in order for all the subarrays of A to be unique. So the problem statement says we have some array A1, A2 up to AN. Okay, we have elements from A1 to AN. If we look at a subarray of it from L to R, we call it a good subarray if there is some element which occurs, which is present only once. Now it gives us some type of operations. Like basically we can choose any element and we can make it any element we want. So like let's say we took this element, we make it n plus 1. Now its frequency n plus, because all the elements are between 1 to n. The frequency of this element would be only 1. So any array which starts from this side and ends on this side would be a good subarray. Or let's say we have replaced this A mid with some element, let's say n plus 10. Then any element which starts before it and which ends before it would be a good array. So you see, like, let's say we have some element. And let's say we have replaced these elements. Then we can always replace it with some large integer such that that integer would be there only once. So at the end of the day, like any left hand side on the left side of this and right side of this would be a good array. Or left side of this and right side of this should be a good array. Or left side of this, right side of this should be a good array. So what we basically need is everything on this side should be good. Everything in between this should be good. Everything in between this should be good. If these are the goods, then we would be able to get it within the 3 operations. Like that is what the problem statement says. Any questions on the problem statement before I jump on like what did I coded in the context? So like once we understand the problem statement, my next idea was again define some DP parameter. DPI denotes like what is the minimum cost, minimum number of changes we should make between first I elements so that everything is good here. And you see now what we need is value of DPN so that everything from 1 to n is good. So like a brute force idea over here would be and you can see like this DP value will always be an increasing value. Because when you add a new element at the back of it, the number of subarrays only decreases. And you may need an extra cost to make everything which ends at here to make it good, or you may not need it. And like this is the idea. Now let's say we want to know like what is the minimum cost we want to make for all A1, A2 up to AI. And let's say we already know the maximum cost for all the arrays before it. We know like dp1 up to dpi minus 1. Then the idea is like we find the maximum length of good array which ends at this, and we keep going it, and everything between them is good. We find some index age such that if you choose anything between these two values, they will be good. Like from aj to ai, like we find the largest j such that from aj to ai, all the subarrays in this segment are good. And but when we try to pick aj plus 1, aj minus 1, eh, there would be some subarray which starts at this and ends in between, which becomes bad. So the idea would be like when we know this largest possible value, we replace this aj minus 1 with some large value, and like we'll take the answer for this side, and we will say like dpi is equal to 1 plus dp of this j minus 1 was replaced. So like we need maximum cost to make first j minus 2 elements good. And because these values are in increasing order, like this j minus 1 would be more than all the values in this segment. And like that is the solution brute force idea. Like does it looks good? And when we keep trying it for all the i's from 1 to n, at last we would get the final answer. Like this finding this j would be a tricky part. And like if you see right now, we know a solution which will get tle. But if we can find this j very fast, then we are good here, right? Okay, like once we know this, like a brute force idea would be like we start with, we have this I, we start with j equal to I, and run a while loop where we do j minus minus, and we take does aj appears like let me write elements like this. Or probably let me just choose some example here. 2 3 2 4 3 6 6. Like let me write it in such a way that for this three, like when I'm looking at this array so far, if I look at these eyes so far, and let's put 6 here as well. So the elements are like index is 1 1 2 3 4 5 6 7. Because of this 6, like because this is the next place 6 occurs, so because of, so everything in this side would be good. Because like this 6, the previous value is at 2, so like we keep on iteratively doing it. Now we know like everything in this segment is good, so we try to find one element over here like which appears only once in this segment. Like let's say this 2 appears only once in this segment, so we look at the next previous value of 2 in this segment, which is this. So now we know that everything which everything which ends at this element index, this area in pink is good because of 6. And now we found one value which appears only once in the segment. Let's say which in this case is 2. So like we look at the previous value of 2, which is here. So we can say like, now we can say like because of this 2, even the pink area would be good as well. Because if you look at this part would be good because of 6. The orange part will be good because of 6. And the brown part will be good because of 2. Like probably let me erase some values. Like first I said like I looked at the previous value of this 6 here. And any starting index in this pink area would be good because like 6 and which ends at this index, because 6 appears only once. Then I looked at one value which is in this segment and appears only once, which is 2. So like I also said like any left index which starts in this pink box will also be good. Because if it starts in blue box, it would be good because of 6. And if it starts in this area, it would be good because of 2. So I know that the previous index where it's good is this area. Now I repeatedly try to find one more element which appears only once, which is 4. And you see like for 4, the previous element does not exist. So anything which we pick as the left index which starts from this 6 would be good. And like if I repeatedly try to find like, if I repeatedly try to increase the answer, at some point we will stop. And like that's the answer we had over here. And like this was the greedy brute force idea I had. Like I will also show the code for this one. Like what about 4? Like because of 4, like once we jump onto the previous value of 6, then we jump to the previous value of 1, and then we find 4 in that area, and because of 4 we jump to outside the grid. So like basically I took all the elements. I have some this PVR index as well. Like for each value, like I know the last 2 values. Like I can probably write this code a better. Like these are the last 2 occurrences of the current value we have. So like I look at the current value and I reassign like the second last value. Like the last value is dot first element, which would be at index r, and second last value would be at whatever the last value earlier it was. And I start with r, like whatever li was, and like mean index is the area up to which I can go, and everything there would be good. And to start with, I can say like if current value v appears, like then whatever its index was just before it, everything would be good because v is there only once in that area. And then I keep going to the left as long as the area is good, which I have with mean index. Then if I look at current value of VL, like which is at index L, first time it will appear here would be VL dot X, and second time it would appear here would be VL dot Y. So because of this VL value, everything which comes, which starts from PVR VL dot Y plus 1 up to R would be good. Like basically, let's say this value known as P1, which is dot X, and P2, which is PR VL dot Y. So we reached at P1 index. Because P1 is main index, whatever we have value so far. So anything which ends at R and is before P1, like we would be good because of some other element. And after, like we have reached P1, like anything after will be good because of what are the current values we have. So like we repeatedly keep doing it and we keep going to the min. There would be some place when we can no longer go to the left part further. At that point of time, like we will take with min value of whatever, like now we will replace with some unique value. In the array. So our like dp value would be dpi minus 1. Otherwise, like dp value remains, like if we have reached to the end, dp value is 0. And at last, we also take with r minus 1 to make everything equal. And like this is the brute force idea. And like this is correct, but this gets TLE. Okay, earlier it got TLE on test set. Why it's going up to TLE on 21? Yeah, 22, but whatever it is. But yeah. So the next thing I did was like you can see like we are getting TLE because of this loop only. So the next thing I did was use segment tree. Where like for each index, I maintain the previous value it existed. So for example, let's take our original array 2632. Four, three, six. At each point, I maintain like previous value where that element existed. Like let me just clear out the extra text ones. Two, six, three, two. Yeah, two, six, two, six, three, two. Like we had four, three, six. So like basically what I did here was like basically like Like for each index, I maintain like the minimum place where that element exists. Probably let me use some other. Just give me a minute. I will create a different board here. Okay, like it's here. Okay, this is working absolutely fine. 2632. So like what I did was I maintained the previous index where all the elements are here. Like let's also assign the index here. 0, 1, 2, 3, 4, 5, 6. So I have secretary. For any element which appears for the first time, I maintain the element of where it appears for the previous time. Like here, like this value would be 1. 3 previously occurs at index 2. Like so in secretary, this value is 2. 4 does not appear here, so I mark it as -1. 2 appears here and the previous value it occurs is at index 0. Then 3, like you see, like 3 is also here, so I mark it as infinity. For 6, you can see like 6 is also there on the right hand side, so I take it as infinity. And like for 2, like there is a 2 on right hand side as well, so I mark it as infinity. So the idea here is like whenever I take some segmentary, like if I query on this hand side, this area, assuming that this area is good, I can get the largest possible jump, which would be in the minimum of this segment. Jump on left side. So for example, if I start with like this as a segment, and if I have previous occurrences of all the elements here, you can see like because of 2, I was able to only jump until 0th index, because from 0 everything starts beginning. But now if I look at minimum in this area, because of this -1, I can directly jump on this complete segment here. And like that was my idea, like greedily trying. Readily trying finding largest jump, and like that was pretty much it. Like I have no proof why like the number of iterations would be very less in this case, just that probably test cases were weak and I was able to get AC. Like, and it can be possible that someone hacks this solution. And like I can probably show like the segmentary. I have this min segmentary, like the same DP idea. I try to find min index and like the same DP states over here. Now for the index I, the previous element it appears is PVRV. So I add +1 to it. Like that's the maximum you can get if you start from R and if you keep going left. And if previous value was not -1, then for this index, you mark it as infinity. Because there is one element on the right hand side which is equal to this element. So like this helps, this gives us nothing here. And like my minimum current index would be the area in which V is unique, which would be this value of V +1 right to it. And while it is true, find the new possible value you can get by looking at the elements from min index and elements up to R which appears. And if you can get some, try to find the largest possible jump. And if current jump does not gives us any better answer, just break here. Otherwise, assign it to the maximum jump you could get in this segment area and keep doing it. Once you make a break, like your current min index -1 would be the element you should replace. So the new cost would be 1 plus PVR cost -1, and I also assign this DPR -1. And like pretty much that was the idea. Like earlier, I was running one element at a time, trying to jump whatever I can. Now instead of doing that, I have two indexes. I jump largest possible jump on the other side of it, and then keep doing it until either I can no longer jump further, or I would be at the end of the grid, which would return me the same answer. And like that was the idea I had. And like this apparently did give an AC. And like I have no proof why like this gives us the small number of like time complexity, like no proof on time complexity. And like this was pretty much the solution I had for this problem. And in a sense, like it's heuristic. Like at least whatever test it had, did pass at that point of time, and it's possible someone hacks it. And like this was my idea for this problem. Any questions on this problem or anything before like I call it a day today? Like I think someone asked why greedy does not works in problem C. Like the problem why I did not choose greedy was like I was able to see a counter test case for it. Like let's say these are the elements 1, 2, 10. What will you do in greedy? You will try to find reduce as much minimum sum as possible. So in that case, like in greedy, you would change this to this 2 first, because this operation gives us -8 as the sum. And then now you have 1, 2, 2. Now the next idea you would have probably to reduce this sum by making this element 1. And now you can probably might again want to do apply operation on this. Then you can see like there are 3 operations here. And like it does not like, but we can also do it in 3 operation, like first replacing this with 1 and then replacing this with 1. So now if you are allowed maximum 2 operations, you would probably print 1, 1, 2, but the answer is 1, 2, 2. The other way around, like probably you have element like this 1, 10, 19. Like let's call it 9, 10, 19. And let's say we have some more elements here. Like let's say we have some elements in between. And we have like the difference here is 9. Like I'm trying to form. Let's say we have 9, 14, and 19. Difference here is 5. Difference here is 5. And let's pick like 60, 66. And then let's say we have some more elements. And here you have 70, 76. By greedy, you probably might change this 60 to 66 by -6. And then you might want to change this 70 to 76 -6 again. But if you see like here, if you do -5 first, make it 9, then you can get -10 here when you make it 9. And like this is obviously better. And like I did foresee like the cases like this, and I had no proof, like no greedy idea what to do in cases like this. And that was the reason I went with DP. And like to be honest, I have no idea how to solve problem F. It's probably some max flow, but to be honest, I don't know how to solve it. And like just 16 people solved it, and I was not one of them. Like some greedy, something people are doing, and some mask and anything. Probably like geothermal did it, and probably I will leave it here because like I don't know how to solve it, and like it's better to wait for editorial than anything else. Looks like some DP. I don't see max flow at least in geothermal side. Like people are using just bitset for this one and trying to chase it. So probably that might be the intended solution. At least studios did bitset use and like geothermal, and like some people are doing different ideas. and like I don't know how to solve this one. सी में सेगमेंट ट्री लगेगा क्या? सेगमेंट ट्री नहीं, सी में सिर्फ डीपी लगेगी. So if there are any other questions from the chat, I would be happy to answer them. And otherwise, I will call it a day today. Like my current rank is 81, but it's possible that this solution gets hacked and I fail below it. Okay. So like this was pretty much it. So thanks everyone for joining today. And next I would be I am planning for Codeserve starter stream. Like tomorrow is the Codeforces due one. I would definitely participate in it. But I'm not sure if I want to stream it or not. Like if I solve some non-trivial number of problems, I might do it. Otherwise, I will rather go for sleep. So thanks everyone for joining today.